Hello everyone, my name is Horace, and in this video we're going to be going through LeetCode number 206, reverse linked list. So for this problem we're given a head of a singly linked list, and we simply want to reverse the list and return the reversed list. So as always, let's go through an example. So for this example we're given this linked list and we want to reverse it. So how can we go about reversing the linked list in an algorithmic way? So we can take each of the links that are present in the linked list and simply change the direction of them. So since this link is pointing towards the right, we simply want to change its direction so that the 2 is now pointing to the 1. We also want to change the head of the linked list to be where the tail of the linked list was. And the tail of the linked list was this node, so this now becomes the head of the reversed linked list. We can also remove this next pointer, which points to null, since this is the head of the linked list. And we have to ensure that the new tail of the reversed linked list points to null, so we can terminate the linked list. So the 1 node points to null. So this is what the reversed linked list will look like after we reverse the original linked list. So there are two solutions to this problem. We can take an iterative approach and a recursive approach. So first we'll take a look at the iterative solution. And for this solution, we're going to be using 2 pointers, a previous pointer and a current pointer. First, we can recognize that the end of the linked list ends in null, and since we're reversing the linked list, we can begin with null. And that means we can point a previous pointer to null. So we can say that we have null, and then the previous pointer points to the null value. And then we also have the current value, and this points to the head of the linked list in the beginning. So we need to make sure that the current pointer is not null. So if the current pointer is not null, we can continue with this algorithm. So first we'll be tasked with updating this next pointer. But if we update this next pointer and change it to point to something else, then we lose reference to the next node and we cannot access it. Then we can create a temporary variable which is going to keep reference to this node, and then we can go back to it anytime. Now that we have a reference to the next node, we can update the next pointer for the current node. So then we can just remove this next pointer and update it to point to the previous pointer. Then we have to update both the previous and the current pointers to point to the next values in the linked list. Well, the previous one is pretty simple. We can simply just change it to be the current, and then the current we can change to be the temporary value. So now the previous pointer is going to point to the node with a value of 1, and the current pointer is going to point to the node with a value of 2. And then we simply repeat this algorithm until cur is equal to null. So let's continue with this algorithm. We first store a temporary variable that stores reference to the next pointer from the node. So the temporary variable is going to point to null. Then we want to update this next pointer and make it point to the previous node. Well, we can just update the next pointer and change it so that it points to the previous node. Then we update the previous and the current pointers, and the previous becomes the current and the current becomes the temporary. So now previous is going to point to this node, and then current is going to be null. And we see that we've reached a point when current is equal to null. So then we can just go ahead and return the reversed linked list, and we can do that by returning previous. And we can go ahead and return previous since this is now the new head of the linked list. And that's how the iterative solution works for reversing a linked list. The time complexity for this algorithm is going to be big O of n, since we need to go through each of the n nodes in the linked list and reverse each of them. And the space complexity is going to be big O of 1, since we're not using any additional data structures. We're just using 2 pointers and reversing the linked list iteratively. With that being said, we can go ahead and write the code for this solution. Okay, we're on LeetCode and we can start writing the iterative approach solution. So first we can begin by initializing the previous and the current pointers. As we said, the previous is going to begin pointing to a null value, and the current, which we'll say cur, is pointing to the head of the linked list. Then we can write a basic while loop which traverses the linked list until current is not null. So we can just say while cur, and it will continue iterating as long as we move the current pointer. Then we can keep a temporary variable which is going to point to the current next pointer, so we have reference to it once we update the current.next. We update the current.next, and this is going to be pointing to the previous node. So we can just set it equal to previous, and then we shift both the previous and the current nodes. So previous is going to be equal to current, and then the current is going to be equal to the temp variable that we set, which is just the reference of the cur.next. Then finally, once the current is none, we can just return the previous node, and this is the entirety of the code. So as you can see, the code is accepted, and we can check out the runtime and the space complexity. So this is the iterative approach for this solution. So for the recursive approach to this problem, we first have to define the base cases of a linked list when we're trying to reverse it. Well, we can take a look at two of the most simplest cases, either when we have a node that is null or when we have a singular linked list, and obviously this is going to be pointing to null. Now for each of these cases, we know that we don't have to actually do anything since a null value is already reversed. But for the other case, we don't actually have to reverse it since we're not concerned with this part. We're only concerned with the node. And if we just take a look at the node, we don't have to reverse anything since it's not pointing to any other nodes with values. That means for those two cases, we can just simply return. First, we begin with the call to the entire linked list since we're calling with the head. Then we call recursively to everything after the head value, so all the nodes, and then again this continues, and then until we reach one of the base cases. So we reach the null value, and then we can simply return from this point. So we recurse backwards, and then we see this base case, which also just is already reversed. Then we look at this recursive step, and we can imagine that the current pointer is at 2. But notice that we also have reference to this node already. So we can simply take this node's next pointer and update it to be the current head pointer. So we take this next pointer and then we update it to point to the current head in the recursive call. Well, what do we do about the next pointer from the current node we're at? Well, we can simply take this next pointer and just remove it. In other words, we can make it point to none or null. So since we're looking at all the nodes now, this is the current node that we're looking at. Then we can take the node's next pointer, but this is pointing to null, so we can take that pointer and update it to point to the head. And then we take the next pointer for the current node, and then we point it to null. And also, while we're recursively calling, this head is updated and the head actually becomes the third node. And since this is because we recursively called until the base case, and then we can just return the node, and then this is the reversed linked list. The time complexity for this approach is also big O of n, but the space complexity in this case is also big O of n, since we have to deal with the recursive stack, and that can be big O of n in the worst case, which is all the nodes. So with that being said, we can go ahead and write the code for this approach as well. So we can begin by writing the base cases. And the base cases we said were when we have a null or if we have a singular node. So we can just say if not head, and this means that it's a null value, or we could say that head.next is not present, which means that it's null, and then this is the singular node. In either case, we just want to return the head. Then we can recursively call, and we'll save this value in a variable called new head, and we'll recursively call the function, so self reverse list, and then we'll call it with the next node in the linked list, so head.next. And finally, we can update the next pointer, so head.next.next, and this is going to be equal to the current node or the head, and then we can update the head next to be simply null. Finally, we would just return new head, and this should be the recursive solution, so we can submit it, and you can see the code is accepted, and this is running in big O of n time with big O of n space. So with that being said, hopefully this video helped you and you learned something, and I'll see you soon.